Alright, so let's continue on the question number 6. It's asking you, according to Westbury, the geometry of sulfur 3 oxide, the molecule is. What is the geometry of this molecule? We're going to do exactly the same thing. We're going to count the number of valence electrons. We're going to make the structure of our molecule. And we're going to have all the octet for the outer atoms. And then we're going to work with the inner atoms. If you have extra electrons, you're going to dump them into the central atom. If you are missing an electron for the central atom, you're going to make double bonds and triple bonds to make them octet. Okay, that's how it works. So let's work on this molecule now. So for sulfur, we have 6 valence electrons, and I have 3 times 6. I have total of 24 electrons. There's no charge, so it's going to be 24 electrons total. I'm going to have sulfur, oxygen, oxygen, and oxygen like this way. So I'm going to make single bonds. 1, 2, 3. So I used up 6 electrons. Each bond has 2 electrons in it. So I have only 18 left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, so now in this molecule, I get all the outer atoms octet, and then when I look at the central atom, this sulfur is not octet, right? It has only 6 electrons around it. This is not good. So we want to have the sulfur octet, so we can have this one of the pairs to make a double bond. It can be this bond or the other one or the other one. So it's either way is okay. So we're gonna make sulfur double bond oxygen. And here 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. All right. So here we have 3 atoms around the sulfur here having one double bond. So now what we're going to do, we are going to find out the geometry. So now we are looking for how many electrons cloud we have around the atom. 1, 2, 3. So double bond counts 1 as well. So if you have 3 electron pairs around a central atom, it's called trigonal planar. It's going to be planar geometry of electron cloud as well as the geometry, because there's no lone pair on the central atom. So we have 3 atoms, so it's going to be trigonal planar. All right, this is for question number 6. So let's work on this geometry of sulfur with 4 fluoride. So I'm going to do exactly the same thing. Let's count the number of valence electrons. 6 plus 4 times 7. 28 here plus 6 is going to be 34 electrons in total. So I'm going to put the sulfur in the center. 1, 2, 3, and 4. I'm going to use 1, 2, 3, 4. 8 used up. I got 26 left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I used up 24. I have 2 left. So what I'm going to do with it, I cannot throw it away. I'm just going to put on the central atom. So yes, you're right if you think that sulfur atom is not an octet here. So this is an exception, right? So we can have extra electrons on the central atom. That's okay. But you cannot have less than 8, right? You should have 8 all the time. Except like barium can have only 2, like helium, right? All right, so he's asking the geometry here. What would it be the geometry? So we're going to look at the clouds. 1, 2, 3, 4, and 5 electron pairs around the central atom. So if you have 5 electron pairs around the central atom, the geometry is called trigonal bipyramidal. Trigonal bipyramidal. That's the cloud, right? We don't want to. First, we want to find out the cloud. So now, once you find out the cloud, what would it be if you have 4 to 1? So, 4 bonding, but 1 lone pair. It's called seesaw. All right. Okay. This is question number 7. So let's do question number 8. It's now here we got phosphorus with 3 chlorine. So I'm going to look at how many lone pairs on how many valence electrons on phosphorus. So I see that it's 5 for phosphorus. I have 5 valence phosphorus from the periodic table. That's 5, and plus I have 7 for each chlorine. 3 times 7 makes 21 right there, and then 26 electrons in total. Let's do phosphorus in the center. What's going on? All right, my computer is excited. All right, so here I'm going to do phosphorus, I'm going to do chlorine, chlorine, and chlorine. I had 26 electrons to use. 2, 4, 6 used up already. I have 20 left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have 2 left. I'm going to put an essential atom, right? All right, that's it. So what would be the geometry here? It's asking what is the geometry. Well, again, we're going to look at the cloud first, and then we're going to determine the geometry. If you have 4 around the essential atom, it's called tetrahedral. Cloud. What would be the geometry of molecules since we don't have any atom for this lone pair right here? So it's going to be 3 of them. So it's going to be called trigonal pyramidal. Okay. If you want to draw the phosphorus, so you're going to have a lone pair on this top. So chlorine here, and chlorine here. All right, this is how it's going to look. So you basically have a pyramid, right? You have a pyramid, and then this electron lone pair is on the top of the pyramid, which we don't see it. So we just see the pyramid here. That's why it's trigonal bottom, and it's called pyramidal, right? All right, so I'm going to do question number 9. So let's do number 9 here. Carbon, this is carbonate, and then we have 4 valence for carbon, and then we have 3 times 6 for oxygen, and then we have 2 for charge, so 24 electrons in total. I'm going to have the carbon in the center, oxygen on the left, oxygen on the right, oxygen on the top or bottom, it doesn't matter. Okay, so we have 24 electrons to use. I'm going to use 1, 2, 3 pairs of electrons, so it makes 6 in total. I have 18 left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 18 electrons used up already. So I ran out all my electrons. Okay, so what I'm going to do now, I'm going to look at the essential atom. Over here, carbon is not octet, right? So I'm going to move one of these electrons to down there. So it's going to be carbon 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and I'm going to make a double bond here. So that's going to be the molecule. What would it be the geometry here? So you have 1, 2, 3 pairs of electrons around it. It's just planar, right? The cloud is the planar as well as the geometry because there's no lone pair on it. All right, so you can stop it anytime and then you can rewatch it. So I just go quick here. So this is how it's done. So it's asking you to find out which one will be the linear, which one of the following species will be linear. So the hydrogen sulfur. So you're going to draw all the structures and then you're going to find out which one is going to be linear. Okay. So let's work on the first one here. We have dihydrogen sulfur. We have 1 electron for each hydrogen. So I'm going to do 1 times 2 plus sulfur. It has 6 on it. So it's going to be a total of 8 electrons. So sulfur, hydrogen, hydrogen. I have 1 here. I used up 4 electrons. I have 4 more left. Hydrogen does not require an octet, so we want to have the essential atom to be octet. 1, 2, 3, 4. So if you have 4 electrons in an essential atom, the cloud will be tetrahedral. And the molecule will be a bent structure. All right, so this is not linear. Hydrogen cyanide. 1 here, 4 here, and then 5 for valence. So we got 4, 9, 10 electrons in total. Carbon, nitrogen, hydrogen. So we don't need octet for hydrogen right there. So we are going to have 6 left. 1, 2, 3, 4, 5, 6. So I used up all my electrons, but the carbon here is not octet. I'm going to move the first pair. It's still not going to be enough, so I'm going to move the second pair. So it's going to work. Hydrogen, carbon, 1, 2, 3. I moved 2 of them. So I have only 2 left on the nitrogen. So when I look at the essential atom here, 2, 4, 6, 8, that's octet. And nitrogen, 3 bonding pairs, and then 1 lone pair, it's 8. So it's all good to go, right? So here I'm going to look at the essential atom, and then I have 1 cloud on the left, 1 cloud on the right. So we have a linear structure here. That's going to be the answer. Okay. So let's work on the boron 3 fluoride. We have a boron here, fluoride, fluoride, and fluoride. So I have boron, I have 3 valence, and then for fluorine 3 times 7, so it's going to be 24 total, right? 24 electrons in total. So I'm going to use 1, 2, 3 pairs of electrons, so which means 6. I have 18 left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I use up all my electrons. And here, we don't want to make the boron as an octet because it's another exception, okay? So boron is an exception. So here, this is obviously is not going to be a linear, right? Definitely not linear because we have 3 atoms around it. So for this molecule, I'm going to have the carbon on oxygen on the center, hydrogen on one side, hydrogen here. So as you do the molecule, you're going to get this. All right, and it's going to be a linear. It's not going to be a linear. And then when you have sulfur dioxide, so we have 6 valence for sulfur, and then we have 6 for each oxygen, so we have 18 electrons in total. So sulfur, oxygen, we use up 2 pairs of electrons, and we have 14 left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I have 2 left. I'm going to just dampen the central atom. So we have octet for the oxygens, but not sulfur. So I'm going to make a double bond, one of them here. So it's going to be like this. What would have been the geometry? Well, it's not going to be linear, right? So it's going to be a bent structure. So answer will be B. That's 10. All right, so question 11. It's asking you what would have been a bond angle. So we have sulfur. Once you do the linear, once you do loose structure here, you're going to get this something like this. All right, so there are 2 of them. So I'm going to make here chlorine. So you will have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you're going to have 2 pairs of electrons on the central atom. So this is going to be a tetrahedral electron cloud, right? Tetrahedral electron cloud. Well, what is the geometry here? It's going to be a bent structure definitely, right? Because we have only 2 occupied pairs of electrons and then 2 lone pairs. Geometry tetrahedral electron cloud, but the structure will be bent. But the problem is that when you have a tetrahedral like sulfur, like all lone pairs, they're all the same, it's going to be 109.5 degree angle. But if you have chlorine on 2 of them, these clouds are huge, right? They are not polarized, so they are huge. They're going to push all the rest a little bit further away. Okay, so these clouds are big, and when you have cloud, they're going to be small. So since this bigger are going to push more than the small ones, it's going to be a little bit less than 109.5. All right. All right, I'll continue on the rest of the questions on the next video. All right, see you soon.